Here, that is the first type of the filter circuit, that is a capacitor filter circuit. In examination there is a question, explain the working of capacitor filter with a neat diagram and waveforms. So that is the question, how the capacitor filter circuit is working. Now in diagram, here the input is shown, that is the output of the input is nothing but that is the output of the rectified circuits. That output is the pulsating DC output of the rectified circuit that is given input to the filter circuit, which is act as an input to the filter circuits. And capacitor C, that electrolytic capacitor C, placed across the rectifier output. Here the capacitor C, which is placed across the rectifier output, and it is in parallel with the load resistor RL. So capacitor C and load resistor RL, they are in parallel, they are connected across the rectifier output. Now how this capacitor is filter out AC component from the rectifier output and provide pure form of DC to the load. As the rectifier output voltage increase, now the rectifier output voltage increase from that way. It charges capacitor C. Capacitor C is now charged when the rectifier output is increased. At the same time, capacitor provide supply current to the load RL. Now whenever the capacitor is charged, as the rectifier output voltage increase, it provide or it supply current to the load RL. At the end of the quarter cycle, up to this point, at the end of the quarter cycle, the rectifier output voltage goes on decreasing. As this occur, capacitor start to decharge. Now as this occur, capacitor start to decharge through the load resistor RL and supply load current, and this process is repeated again and again, so we will get the pure form of DC at the output. Shortly, capacitor C here pass AC component through it. Capacitor C pass AC component through it and it block DC component, that DC component which is applied across the load RL, so we are getting pure form of DC to the outputs. So that is the working of capacitor filter circuits. It is very simple. As the rectifier output voltage increase, it charges the capacitor and also supplies current to the load RL. At the end of the quarter cycle, the capacitor is charged to peak value of rectifier output voltage. Now the rectifier voltage start to decrease. As this occur, the capacitor start to decharge through the load resistor RL and supply the load current. This process is repeated again and again, so we are getting pure form of DC to the output. That is the working of capacitor filter circuit. Capacitor filter circuit C pass AC component through it, but it block DC component. That DC component which it is appear across the load RL. That is the working of capacitor filter circuits. Capacitor filter circuits, it is widely used due to its small size. Capacitor filter circuit is widely used due to its small size, at low cost and good characteristics. Mostly in DC power supply, capacitor filters are used due to its small size, low cost and its good characteristics. Now the second type of the filter circuit, that is called as the choke input, that is called the inductor filter. In examination there is a question, explain the working of choke input filter circuit with a neat diagram and waveform. Here the diagram is shown. In that diagram, inductor coil L and capacitor C are used. One inductor coil and one capacitor is used. The inductor coil, it is connected in series to the rectifier output, but capacitor is connected across the rectifier output. The pulsating DC output of the rectifier circuit, here the pulsating DC output of the rectifier circuit is applied across the terminal 1 and 2 of the choke input filter. As we know that property of inductor L shows higher opposition. Inductor L shows higher opposition to the AC component. It block AC component. That is it block AC component. Inductor block AC component and pass only DC component through it, because it shows very low opposition to the DC component, resulting that it reduces pulsation at terminal 3. At terminal 3 we are getting only DC component because AC component is blocked by the inductor L. Now capacitor C, what's happened? The capacitor C bypass, negligible amount of AC component. Capacitor C bypass negligible amount of AC component, which is unblocked by the choke L or inductor L, and it block DC component, which is applied across the load RL. So we are getting pure form of DC at the output. So in choke input filter or inductor filter, the pulsating DC output of rectifier circuit is applied between terminal 1 and 2 of the filter circuit. Inductor L or choke L shows higher opposition to the AC component and low opposition to the DC component, so that inductor L that block AC component of the rectifier output and it pass DC component through the load. Now at terminal 3 what's happened? At terminal 3 capacitor C, that electrolytic capacitor C, that bypass negligible amount of AC component, which is unblocked by the choke L, and it block DC component, which is applied across the load RL. So we are getting pure form of DC at the output according to that waveform. Here the waveform is shown. So we are getting pure form of DC at the output. In this way, the choke input filter circuit pure form of DC as compared to the capacitor filter circuits. That is the working of choke input or inductor filter circuits. It is a combination of inductor L and capacitor C. Inductor L is connected in series with the rectifier output and capacitor C is connected in parallel to the rectifier output. Here double action of the filtering take place, so we are getting most pure form of AC output voltage.